Hello, guys. Welcome to another episode of Cuda Education. So, today we are moving on to step six. So, we are on step six now. And what we are doing is we are talking about all things textured material. As you can see from the graphic in front of us, we now have an updated scene with materials associated with the assets in our scene. You could see that, things look a little bit more realistic. The colors aren't off. Still a lot of work to do, but we do have an improvement. So this series now, I guess we'll call this Clean Slate 3.0, dealing with textured material. We'll discuss all things related to managing textures and applying it to the correct assets in our scene so that we have a better a better outcome. We could see that we kind of have somewhat of a driveway now. We have walls. The windows are colored. The door is colored. The tree is a little bit, looks a little bit more natural, like what we expect it to see. And we have, the driveway and all the outdoor artifacts, sort of in a better state. So for this particular 3.0 video, we're just gonna go over all the things that all the steps associated with making this improvement, mainly dealing with textures and materials and things related to that. And that's it. That's all we're doing for this particular episode. So let us get into it. So this is step 6, textured materials, right? Context. Step 5, which is the previous, Clean Slate 2.0 series, right? Clean Slate, 2.0 series. Step 5 renders the bistro scene with normals as colors, proving the asset pipeline works. Now we replace that visualization with actual texture sampling so the scene looks realistic. We use a simple per draw texture binding approach, no argument buffers, where each submesh gets its base color texture bound before drawing. Okay, files to modify. So we're still at 2 files. APL simple.metal, add UV coordinates and texture sampling. Changes to mesh vertex in, add float to text chord, attribute APL vertex attribute text chord. Changes to mesh vertex out, add float to text chord to pass UVs to fragment shader. Changes to vertex mesh shader, pass in text chord through to out text chord. Replace fragment mesh shader. Add texture 2D float, base color texture, texture 0 parameter. Add constant float 4 fall and fallback color, right? Parameter. Create a sampler with a linear filtering and anisotropy. If texture is bound, non-zero dimensions, sample it at in text chord. Otherwise, use fallback color. Now, we can detect if a real texture is bound by checking base color texture.getWidth is greater than 1, since the fallback texture is 1 by 1. APL renderer.m. So that was this was all in APL simple.metal. Remember, APL.metal files is shaders, which means it's GPU instructions, code that run on the GPU, things of that nature, right? And then we have number 2, APL renderer.mm, add UVs, bind textures per mesh. This is more CPU side code. Right. New imports. Import APL material.h to access material base color and texture hashes. New IVAR, MTL, ID MTL texture, fallback texture. A 1x1 white texture for materials without base color textures. I don't. Maybe some of the materials in the scene is using fallback. Changes to load metal with view. Add UV attribute to vertex descriptor. Attribute APL vertex attribute text chord, float 2 buffer index, APL buffer index vertex mesh generics, stride 8. Create fallback texture 1 by 1, RGBA 8, unsigned 8U norm filled with white. At some point we'll mess around with this, hopefully, and see if we get a difference. So we know what is using the fallback texture. Changes to draw in MTK view. Bind mesh.uvs at APL buffer index vertex mesh generics. Call texture manager, make resident for encoder to make heap textures accessible. In the submesh loop, for each submesh, look up material, mesh.materials, submesh material index, get base color texture, texture manager, get texture, material, base color texture hash, out current MIP null. If texture found, bound it at index 0. If not, bind fallback texture. Set materials base color as fragment bytes at APL buffer index fragment material. Used when no texture. And issue draw call. All right, so we're looking at some other big picture stuff. So that was, all of this was APL renderer.mm, right? All of this right here. And then this up here was, again, APL simple.metal, GPU side stuff. Okay, no new files. All changes are in existing files. The texture manager already loaded all textures in step 4 and step 5. Okay, step 4 and 5. Okay, verification. Build 0 errors. Run. The bistro scene should show actual brickstone, wood, metal textures instead of the normal color visualization. Materials without textures will show their fallback base color, which I believe is white. Right, so is this the fallback base color? Maybe, but this isn't necessarily full white, but okay. All right, and that's it, guys. That's it. That's all I want to discuss this episode. So we're gonna kind of go through these things in more detail. Not too much detail, but just enough so that we could sort of follow the drift of what's going on, and then later on in the process, after we have our full scene completed, we will dive into more detail in each of these steps. But we do have our overview here for textured materials, and we are well on our way of understanding what's going on in this application, right? So if you're new to the series, we started with a fresh, brand new basic Xcode project. So we do new project, Xcode. Xcode is Apple's GUI for programming all things. So we start with a fresh Xcode project, and then we work our way up to the modern renderer project, which is probably the most advanced application in the Apple Metal sample library. You could Google the Apple Metal sample library and look up modern renderer, one word, and you will see that it's a scene of a bistro scene, right? And it's fully developed. It has a skyline. It has, it has a sky. It has fog. It has lights. It has textures. It has, architecture. The whole works. So we're actively trying to move from a base, fresh code with nothing in it. Basically a metal project, right? Start a brand new metal project with nothing in it, and then make our way to that bistro scene. It is 16 steps total. We are now at step 6, so we have 10 more steps to go outside of this step. So 16 steps. We started off with a blank screen with just a background. Then we had a triangle, and then we had what we see now, the object with the building and the driveway and stuff, but the colors were way off. And then now we have that scene with a little bit more realistic colors and stuff, and that's basically because of these textured materials that were implemented in the project. So we're well on our way, guys. As I learn, you learn, and we all learn. Apple Metal is definitely, here to stay. It allows you to understand and program your GPU, and basically program Metal Apple devices, right? The whole Apple ecosystem runs on Metal. There are of course other programming things, but as far as the computer graphics side of the equation, Apple Metal is where it's at. So anyway, this is Cuda Education, guys. You know what to do to, you know what I mean, to build the community and help the channel. I don't want to repeat it again, but if you know anyone that's artistically inclined, get them involved in your community. Digital is the way of the future in one way or the other. So might as well you start getting your hands dirty from now. Thank you guys for watching. Have a great day.